Now, a moment before I'm giving you the power of moving the slides, the mighty power. So you are the last one, but you are definitely not the least one. I am honored to introduce you. If you are not familiar with Naore Azenkut, he is an highly respected tech expert in the Salesforce ecosystem. As a former senior program architect at Salesforce, he was leading financial institutions. He brought back then in Salesforce, but still brings extensive knowledge and cyber perspective to the table. And also as the co-founder and the chief technology officer at Enforce, now is playing a pivotal role in driving cybersecurity innovative. Now, the stage is yours.
So that's one hell of an intro. So thank you very much for that kind words. So hello everyone. Thank you for being with us. I know it's been an hour and a half and I'm the last session, but I will try to make it as jumpy as possible and make sure that everybody is interested. We are going to build on top of the previous talks. So we've had Tanya discussing the growing attack surface and the level of insecure software, and we've had other great talks that discussed what we need to do. And the problem is everything costs money, and we need to understand how to do it cost effectively. In order to get to a position where we can have 2 architects per 160 developers, we need to understand how to better leverage our budget. So today we are going to take a look. Let me see that my slides. Yeah. So today we are going to have some story time where I will be sharing with you a story about an employee, Avivit, that caused some mess. We are going to briefly discuss some new threats that are existing in this space. We will talk about some hidden costs of defending ourselves in multiple ways, and take it from there to a case study and key takeaways. At the end, we will get to actual numbers. We will build towards it. So without any further ado, I'm going to jump into the story time. So we will start with Trusty Insurance. Trusty Insurance is a medium insurance company. They are growing very fast. One day they discovered their data was being sold on the dark web. They started seeing critical business data, critical customer data, and obviously they started the investigation. They looked over and under and tried to understand what's going on. They looked at maybe it was an outsider, maybe a departing employee that took some data, maybe even a human error. Eventually, they traced it back to Avivit. The stolen data was on her PC. Avivit obviously was in a crying mess, thought she was going to jail. All the fingers were pointing at her. But after an extensive investigation, they figured out weeks ago she fell to a phishing attack. She received a phishing SMS, she opened the link, and unbeknownst to her, an attacker gained full access to her Salesforce account, meaning he had access via API to all of her records and the sensitive customer data. The attacker leveraged large language model AI to generate the extremely convincing SMS in this scenario. And this really speaks to what previous speakers talked about, which is the leveraging of AI by attackers in multiple ways, and every possible angle is being leveraged, including the human factor. At the end of the day, we had a huge data leak due to a single click. And the outcomes were loss of business, loss of customer trust. There were weeks between incident and discovery. One user mistake led to a company-wide impact. That is not a situation a company should tolerate. There should always be safeguards and be foolproof. People make mistakes. And the legacy approaches were not able to cost effectively mitigate this issue. We will soon discuss, when we will talk about the case study, what are the alternatives. Generally, innovative approaches and paradigm shifts towards AI, user behavior analysis, and being application native. That was a quote from the future. So maybe we should just avoid phishing. It's easy enough not to open links from an SMS. So just to think about it, this looks like an innocent cable. I can assure each and every one of you that if I took 3 cables and put them in your parking lot, someone would pick it up. Maybe not in this conversation, people here are aware, but this cable is the OMG cable. It gives me full remote access. It gives me Wi-Fi and Bluetooth even when we have air-gapped systems. It can completely self-destruct and prevent investigation from figuring out what happened. And worst of all, it's extremely cheap. We can buy them in bulk. So the human factor is something that should always be considered in a broader sense. People make mistakes. People bring the attackers into our doorsteps. And yeah, training can go a long way, but it's much easier to train developers, as hard as it is. But it's easier to train developers and IT folks than it is to train a Vivit from HR that really just wanted to, I don't know, do a thing. So when we're looking at the broad spectrum of human factor, we see a common denominator. The common denominator is the user behavior. Something somewhere did something that is strange. Even when we look at different vectors of attack, we have a large exploit of legitimate users. We have a very sophisticated attack spectrum, and defending against it traditionally is extremely resource intensive and extremely business impacting. We will soon see some of the legacy approaches that we see currently being phased out, and talk about how cost effective it would be to move forward. So user, this brings me to the next slide, which is a solution to the problem. How can we better understand, how can we better prevent the broad spectrum of human behavior issues, and how can we do it in a cost-effective way? So I'm going to suggest an alternative title to this talk: AI disruption in the application security space. So I'm not going to cover all of it, it's a huge topic, but we are seeing an emerging paradigm where by being native to the application, by being AI driven, by having the ability to completely, or to a large extent, understand the device, user, and application context, we can build smart and accurate AI systems that automate the security policies generation, that do the anomaly detection by understanding the user behavior. If somebody is going to leave the company and decides to take some leads, take them with them to the next company, by understanding user anomaly, we can detect it, we can understand it, and we can block it. So this is what we're currently seeing. Now, quick definition, just to make sure we're talking on the same thing. From our perspective, an application native security solution is a security solution that runs natively, meaning within the application or the business application, or wraps the business application. And it runs on the cloud provider software and hardware, but it is within the customer control and context. So if you're talking about Salesforce, which will be the case study in a sec, the firewall is not an application native security. It's something that's controlled by the vendor and is provided by the vendor. By providing the customers with the ability to control certain aspects of the security stack, all of a sudden we discover that we have the native capabilities and the robust AI that provides the value. Moving on, I really want to get to the more numbers and nitty-gritty. So solving for the human factor is hard. Innovative approaches allow for huge cost savings, and I will do my best to convince you that in the case study, which is the next slide. The key from our perspective is understanding the user behavior in the application context, which provides precise AI anomaly detection, meaning we understand what the user does, when he does it, why he does it, is it something that they should be doing, and being able in real time to block it. So this is the core concept of having the anomaly detection on a native application. And obviously, it completely complements current network and endpoint protection. We still need to protect the devices. We still need to protect the network. Let's jump into the case study. So, enterprise financials. Enterprise financials is a huge enterprise financial company. They have heavy internal and external compliance. And for our case study, they are doing a Salesforce greenfield deployment. They are going all in, full customer data, Sales Cloud, Service Cloud, mobile. They are going to link it up in the complex IT landscape, meaning it will have complex integrations, lots of users, mobile, public website, everything. Now, when they started looking at it, they started with a very simple approach. So we have employees, we'll do some VPN, we'll connect the on-premise directly to Salesforce. Great. But then they talked a bit and they understood the risk we were talking about so far. There is a gap. Understanding the user behavior is a must, and we want at least a very simple DLP, something that will be in the middle. So they put a CASB, Cloud Access Security Broker. This CASB happens to be inline. Sometimes it's also in listening mode. And then they said, okay, what about the AWS, Azure, and other clouds? What about the customer mobile and desktop and laptops and whatever? And this is an issue because if we take the entire infrastructure of the customer and just plug it in via the CASB, and we're getting into serious issues. It's compatibility, it's network, it's security, it's scalability. And if we connect it directly to Salesforce, well, then we don't, in this approach, don't have the protection we need and don't have the ability to prevent and response based on user behavior. Now, even if we could connect all of that stuff directly through the CASB into Salesforce, it would still leave Salesforce vulnerable. Like, we protect the devices, which is great. But at the end of the day, in the middle, we have the application, we have the data source, and that data source is globally available. The ability to understand each transaction that enters into the cloud is truly only possible when we're leveraging the vendor itself. And just for comparison, so this is the question mark and a bit complicated diagram, and this is the simpler one, where we see a two application native security solution called Enforce, which is our solution, so I am biased. But what it does is simplifies everything in terms of connection and monitoring. So everything is connected to the standard Salesforce APIs, the standard application APIs, the standard application UI. There is zero man in the middle. However, on the Salesforce cloud, each transaction is being processed by an AI anomaly detection engine in real time, where it is able to either block or allow. Also, it is able to provide a single monitoring stream instead of hundreds of monitoring APIs. That's moving for a sec. So just to overview the classic versus native platform security, and the next slide is already about cost, and we can take it from there for questions and whatnot. So when we're talking about the classic approach, we are talking either about the CASB in inline or API mode. They have their own advantages and disadvantages in their place. However, being able to do things natively on the platform simplifies maintenance. It allows for infinite vendor scaling, and it allows for many other things. The title integration to the native part enables the protection of the data on the application in an automatic fashion. It automates the playbooks. It makes the monitoring and incident prevention much, much, much simpler. For example, instead of doing DIY policy rules on 150 monitoring APIs, when you're looking at Enforce, we provide a single one that already digests the entire information. So we get actionable alerts instead of just raw data that go figure out what you do with it. So the case study is essentially a financial enterprise going live and that considered either going old school, DIY, CASB, with the high implementation cost that it means, or leveraging an application native security that is AI anomaly based and is tightly integrated into the application layer. Okay, so let's jump in for some costs. I see that we're still at 44, 45 participants, so this is really great. I'm happy that the retention since I started talking is 100%.
Or they fell asleep. No, but
yeah,
people are
so,
asking and listening.
Yeah, so it's really nice to see that everybody are still on board. So let's really jump into why we are talking about it, right? So far I've talked about the operational advantages at high level and the security advantages of understanding the application context, but we have yet to talk about the cost-effective part of the this talk. So when we are looking at the left column, we see the classic approach. Building it is roughly $1.2 million for an enterprise that we discussed. Obviously, it scales down as the organization scales down. This includes licensing and internal headcount and subscription fees and everybody that is needed in order to implement a custom security model, including extremely costly consultants and vendor support and whatnot. So we are talking at a very, very high DIY cost. We are talking at a long time to execute, so 3 to 6 months. Ideally, honestly, most financial customers at this scale will take significantly longer. There are always hidden headcount costs where all of a sudden you need 4 people to monitor instead of 3, and you don't necessarily calculate it into your budget, but somehow it goes. We have business challenges. So let me give you an example and really another story, but just happened a few weeks ago. A very large insurance company actually stopped a new line of business from going live due to security concerns. The requirements were above their budget, and that's when they came to us. We were able to, within a week, provide the installment and go to live of the solution, which completely covered the requirements. And now they've moved ahead with the implementation project. So we can really show that by reducing cost and time to value in terms of security applications, it allows greater business agility and greater business value. It's not only money being saved from the security perspective, it's also gaining the business agility. And by native and being low maintenance and by being minimal ongoing effort, we are able to provide, or we see that the native application security, the solutions that sits on top of the application, on top of the vendor, are able to provide quicker times to market, quicker or much lower cost, and honestly, much better results. Since we are completely native, the ability to train the AI on the user behaviors of different companies and then retrain it on a specific user really gives much, much better results. And this is the disruption. So we are seeing an order of magnitude drop in early cost. We are seeing 2 orders of magnitudes in the build cost, and we are seeing better security results. And this brings me to the final takeaways. This market is currently being disrupted. We are seeing attackers leveraging AI and companies becoming more vulnerable on the one hand. The other hand of the disruption is that the capabilities of various cloud vendors to provide that native security, the capability is going, and we are seeing solutions like Enforce that enable very, very simple and seamless integration to customer existing systems while enabling the business and reduce the TCO. Yeah,
Thank you.
so that's pretty much
a couple of questions.
Yeah.
So if you want to take a sip of water while I'm reading it, no problem at all. First question. Since you mentioned real-time analysis, can you shed some light on the performance impact? of
Yeah.
such a solution
So-
like yours?
So this is one of my favorite questions. So it really depends on our definition of real time. Since we are talking real time web, the common definition that we work with and Salesforce work with is under 200 millisecond time server processing per transaction. So it's not real time, like a nanosecond where you really need the tight loops. But in terms of web, we usually add under 10 milliseconds. We've done extensive performance testing, and the lawyers don't allow me to commit to it. But the impact that we see is under 5% and single digit in milliseconds. So the training phase is obviously completely different. So once the model training could take a long time, it depends on how active the user, how active the environment, how much data do we have that correlates to the specific use cases. But once the training is complete, the actual inference phase, so the real-time analysis is fairly quick. We also segregate the complexity layers to one layer, which is real-time, which can actually block the user and show him like an error. And a slower, more deep network that runs asynchronously and are able to provide near real-time events. So it's not in the millisecond scale, it's in the second scale.
Okay, thanks for that. Since you mentioned the layers, so that's a different type of an higher level of layers, but what are the protection layers that basically you suggest when considering such as tools like yours or any other one, when thinking about CASB replacements or anything like this?
So I'll quickly jump to maybe this. So it depends on the use case and the threat model. I think Tanya touched a bit on our lack of ability to give one answer that fits all and how frustrating it could be. At the end of the day, we need to look at the use case and the threat models. So if we have a federal bank, I would advise completely different to if we have a small pharmacy. We need to look ground up from the development process all the way to production, but also once in production, understand that we need to protect the devices, we need to protect the networks, and we need to protect the applications. From a CASB perspective, if we are looking at multi-cloud and we want to consolidate the monitoring and control, and a CASB is a good tool. For applications that do not have internal capabilities, CASB is still the most current approach. But when we look at clouds such as Salesforce and other large vendors, we see that the ability for solutions like Enforce to be built in and baked in provides the TCO and security advantage we've been discussing.
What is your approach to data encryption? Where does that one data encryption enters?
So the the two-word answer is do it. The longer answer is we need to be mindful of functional and performance implications. We need to understand what data we are trying to protect and does it really require encryption. And we also need to separate between different levels of encryptions. So for example, Salesforce that sits on top of AWS provides the standard native AWS encryption, but also provides a higher tier of services that allows for various tools for customer control of the encryption process and fields and whatnot. So we need to be mindful of the functional implications, though. Some of those solutions really impact performance and prevent certain functionalities from happening. Usually, when we see a very large financial institution, I would add at least 15% to the development effort in order to be able to work around those encryptions and still provide the functionality that is needed in a performant way. But do it when we must and do it only when needed, and that usually alleviates a lot. we see a lot of extremes. We see either customers that purchase encryption and don't use it, or customers that purchase encryption and just try to encrypt everything. Both approaches don't work. We need to find the middle ground.
And one last thing, still trying to figure out from the question, where does it stand or where does it fit? But does Enforce provide any type of protection against ransomware if that vector of attack is trying to, in this case, affect Salesforce or any other SaaS solution?
So if I'm hard pressed to answer the question, I would say yes, because when ransomware will try to encrypt, assuming the ransomware affects the customer of Salesforce, so the user, not the actual vendor backend.
We are not taking responsibility for Salesforce. That was your job back then.
That's not part of my shared responsibility, exactly. So when the user will try to encrypt the data on the Salesforce cloud as the part of the ransomware attack, they will have to do various APIs and do a bot that runs on the web. So there will be a suspicious behavior. This is something that is very natural for the AI and the normal engine to discover as extremely weird. It's not something that they usually do. However, there are layers of defense, and this is the last line of defense. Like, you need to block it in real time. I would also advise on a proper backup strategy. I would also advise on the endpoint protection strategy, and really look at how we can holistically protect the entire organization, where protecting the specific application is a piece of it, that should be able to respond in the case of an incident and remediate if something really bad happened.
So thanks for that one. So that basically was the last question. Thank you very much, Naor. And again, thanks everyone. Just a quick reminder that, all the slides that you saw today, or the entire recording of the meetup, maybe some more answers to some of the questions that you asked. They are all going to be shared later on. You will find them on our LinkedIn page and our Meetup page. There is also a link in the chat. If you missed it, use it. If you're a member of either ISC Square or ISACA, whether the Israeli chapters or others, feel free to fill in the information, and we'll report the CPE hours for you. It usually takes up to 30 days, so please double check later on your portals that it's being reported. And if you need some help, feel free to approach us, and we'll even provide with a proof that you were here, just in case that's the case and you don't see the report. Until next time. Thank you very, very much.
Thanks
See
so
you.
much.
Bye-bye.
Yeah.